Also, canvas military stretchers and hospital gurneys were used, a procedure recommended by a dummy manufacturer, to move the dummies in the laboratory or retrieve dummies in the field after a test. The first 10 dummy drops also utilized black or silver insulation bags, similar to body bags, in which the dummies were placed for flight to guard against equipment failure at low ambient temperatures of the upper atmosphere. On one occasion northwest of Roswell, a local woman unfamiliar with the test activities arrived at a dummy landing site prior to the arrival of the recovery personnel. The woman saw what appeared to be a human embedded headfirst in a snowbank and became hysterical. The woman screamed, "He's dead, he's dead." It now appeared that anthropomorphic dummies dropped by high-altitude balloons satisfied the requirements of the research profile. However, the review of high-altitude balloon operations revealed what appeared to be explanations for some other sightings of odd objects in the deserts and skies of New Mexico. End of Section 2. Recording by Aaron Bennett. Section 3 of The Roswell Report, Case Closed, by James McAndrew. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Aaron Bennett. The Roswell Report, Case Closed, by James McAndrew. High-altitude balloon operations. Section 1.3. High-altitude balloon operations. Research has shown that many high-altitude balloons launched from Holloman Air Force Base, New Mexico, were recovered in locations and under circumstances that strongly resemble those described by UFO proponents as the recovery of a flying saucer and alien crew. When these descriptions were carefully examined, it was clear that they bore more than just a resemblance to Air Force activities. It appears that some were actually distorted references to Air Force personnel and equipment engaged in scientific study through the use of high-altitude balloons. Since 1947, U.S. Air Force research organizations at Holloman Air Force Base, New Mexico, have launched and recovered approximately 2,500 high-altitude balloons. The Air Force organization that conducted most of these activities, the Holloman Balloon Branch, launched a wide range of sophisticated and, from most perspectives, odd-looking equipment into the stratosphere above New Mexico. In fact, the very first high-altitude data-gathering balloon flight launched from Alamogordo Army Airfield, now Holloman Air Force Base, New Mexico, on June 4, 1947, was found by the rancher and was the first of many unrelated events now collectively known as the Roswell Incident. High-altitude polyethylene research balloons. In 1946, as a result of research conducted for Project Mogul, Charles B. Moore, a New York University graduate student working under contract for the U.S. Army Air Forces, made a significant technological discovery: the use of polyethylene for high-altitude balloon construction. Polyethylene is a lightweight plastic that can withstand stresses of a high-altitude environment that differed drastically from and greatly exceeded the capabilities of standard rubber weather balloons used previously. Moore's discovery was a breakthrough in technology. Scientists were able to make detailed, sustained studies of the upper atmosphere. Polyethylene balloons, first produced in 1947 for Project Mogul, are still widely used today for a host of scientific applications. High-altitude polyethylene balloons and standard rubber weather balloons differed greatly in size, construction, and utility. The difference between these two types of balloons historically has been the subject of misunderstandings, in that the term weather balloon is often used to describe both types of balloons. High-altitude polyethylene balloons are used to transport scientific payloads of several pounds to several tons to altitudes of nearly 200,000 feet. Polyethylene balloons do not increase in size and burst with increases in volume as they rise, as do standard rubber weather balloons. They are launched with excess capacity to accommodate the increase in volume. This characteristic of polyethylene balloons makes them substantially more stable than rubber weather balloons and capable of sustained constant level flight, a requirement for most scientific applications. The initial polyethylene balloons had diameters of only 7 feet and carried payloads of 5 pounds or less. As balloon technology advanced, payload capacities and sizes of balloons increased. Modern polyethylene balloons, some as long as several football fields when on the ground, expand at altitude to volumes large enough to contain many jet airliners. Polyethylene balloons flown by the U.S. Air Force have reached altitudes of 170,000 feet and lifted payloads of 15,000 pounds. During the late 1940s and 1950s, a characteristic associated with the large, newly invented polyethylene balloons was that they were often misidentified as flying saucers. During this period, polyethylene balloons launched from Holloman Air Force Base generated flying saucer reports on nearly every flight. There were so many reports that police, broadcast radio, and newspaper accounts of these sightings were used by Holloman technicians to supplement early balloon tracking techniques. Balloons launched at Holloman Air Force Base generated an especially high number of reports due to the excellent visibility in the New Mexico region. Also, the balloons, flown at altitudes of approximately 100,000 feet, were illuminated before the Earth during the periods just after sunset and just before sunrise. In this instance, receiving sunlight before the Earth, the plastic balloons appeared as large, bright objects against a dark sky. Also, with the refractive and translucent qualities of polyethylene, the balloons appeared to change color, size, and shape. The large balloons generated UFO reports based on their radar tracks. This was due to large metallic payloads that weighed up to several tons and echoed radar returns not usually associated with balloons. In later years, balloons were equipped with altitude and position reporting transponders and strobe lights that greatly diminished the numbers of both visual and radar UFO sightings. One classic misidentification of a Holloman balloon that was mistaken for a UFO was launched on October 27, 1953. According to the following account published in a widely distributed 1958 history of Air Force balloon operations, Contributions of Balloon Operations to Research and Development at the Air Force Missile Development Center, Holloman Air Force Base, New Mexico, 1947 to 1958, a suspected Holloman balloon was tracked both visually and by radar over London, England on November 3, 1953. English accounts of the incident contain such statements as tremendous speed, practically motionless, circular or spherical and white in color, emitting or reflecting a fierce light. Altitude was reported as 61,000 feet, and as no research balloon had recently been sent up from Britain, there was ample room for local saucer enthusiasts to claim the unidentified flying object as proof of their theories. A much likelier explanation, however, is that this was really the balloon launched from Holloman on 27 October. High-altitude balloon payloads. Over the years, payloads transported by high-altitude polyethylene balloons range from simple radio transmitters to anthropomorphic dummies to sophisticated satellite components and NASA interplanetary space probes. Many of these payloads, some of which weighed many tons, were not what someone would typically envision as being associated with a balloon. Examples of payloads flown in New Mexico by Air Force high-altitude balloons can be found on pages 52 and 53 at the end of this section. Research projects of the late 1940s and 50s conducted at Holloman Air Force Base, which began with the Project Mogul flights in June 1947, covered a wide spectrum of scientific research. One important experiment in space biology measured the effects of exposure to cosmic ray particles on living tissues. Other projects gathered meteorological data and collected air samples to determine the composition of the atmosphere. The first high-altitude photographic reconnaissance project, a forerunner to today's reconnaissance satellites, Project 119L, also used high-altitude balloons launched at Holloman Air Force Base. As early as May 1948, polyethylene balloons coated or laminated with aluminum were flown from Holloman Air Force Base and the surrounding area. Beginning in August 1955, large numbers of these balloons were flown as targets in the development of radar-guided air-to-air missiles. Various accounts of the Roswell incident often described thin, metal-like materials that, when wadded into a ball, returned to their original shape. These accounts are consistent with the properties of polyethylene balloons laminated with aluminum. These balloons were typically launched from points west of the White Sands Proving Ground, floated over the range as targets, and descended in the areas northeast of White Sands Proving Ground where the strange materials were allegedly found. In 1958, the first manned stratospheric balloon flights were made from Holloman Air Force Base. In 1960, balloon tests of components of the first U.S. reconnaissance satellite were also flown at Holloman Air Force Base. In the 1960s, 70s, and 80s, high-altitude balloons were used in support of Air Force and other U.S. government and university-sponsored research projects. Instrument testing of atmospheric entry vehicles for the National Aeronautics and Space Administration, NASA, space probes is one prominent example. The Surveyor, Viking, Mars, Pioneer, Venus, and Galileo, Jupiter, spacecraft were tested by Air Force high-altitude balloons before they were launched into space. Viking and Voyager Mars space probes, examples of unusual payloads not likely to be associated with balloons, were qualification trials of NASA's Voyager Mars and Viking space probes. Both of these spacecraft look remarkably similar to the classic dome-shaped flying saucer. In 1966 to 67 and 1972, 8 of the UFO lookalikes were launched by the balloon branch from the former Roswell Army Airfield, now Roswell Industrial Air Center, New Mexico. The spacecraft were transported by Air Force balloons to altitudes above 100,000 feet and released for a period of self-propelled supersonic free flight prior to landing on the White Sands Missile Range. While the origins of the Roswell scenarios cannot be specifically traced to these vehicles, their flying saucer-like appearance and the fact that they were launched exclusively from the original Roswell incident location leaves an impression that perhaps these odd balloon payloads may have played some role in the unclear and distorted stories of at least some of the Roswell witnesses. Tethered balloons. The Holloman Balloon Branch, in addition to high-altitude research activities, also conducted low-altitude tethered balloon flights. It appears that the descriptions of these balloons may have become part of the Roswell incident. Most standard-shaped tethered balloons are readily identified when near the ground or when the tether is visible. Other experimental tethered balloons are not so easily identified. During the 1960s, balloon branch personnel flew experimentally shaped tethered balloons from deep canyons of central New Mexico. To a distant observer, from a vantage point above the canyon rim, where the tether and ground anchors are not visible, an experimental tethered balloon might lead some persons to speculate as to the oddly shaped balloon's origin and purpose. One design of a low-altitude tethered balloon may have inspired at least one account of an alien craft. In The Truth About the UFO Crash at Roswell, the authors published a drawing of a crashed alien spaceship allegedly based on a drawing given to them by an anonymous witness. When this drawing is compared to a photograph of an experimental tethered balloon flown at Holloman Air Force Base in March 1965, the similarities are undeniable. The tethered balloon and the NASA space probes are just two examples of the uncommon technologies that were flown in New Mexico by the Holloman Balloon Branch. Today, the Air Force maintains a reduced but still highly capable high-altitude balloon program at Holloman Air Force Base. The Space and Missile Command Test and Evaluation Unit, SMCTEOLAC, represents the sole Department of Defense high-altitude research balloon capability. The ability of the U.S. Air Force high-altitude balloon to lift a scientific payload to more than 100,000 feet, above 99% of the Earth's atmosphere, for days at a time, presents a